Now, in order to see what at x is equal to 0, what we do here is at x is equal to 0, we got f double dash x is equal to 0, which was indecisive, right? If we had got greater than 0 or less than
Yes, sir.
0, then we would have said that uh, it is a point of local maxima or minima. Okay, but we are getting f double dash x is equal to 0. Then what do we do under this circumstance? Remember that whenever you get f double dash x is equal to 0, that is the second derivative equal to 0, you find f triple dash x, that is the third derivative. Remember,
Okay.
whenever you get f double dash x is equal to 0, you find f triple dash x, that is you find the third derivative. And what is the third derivative here? The third derivative, if you differentiate this one, you will get 60x square minus 120x plus 30, right? So at now what we do here is, now we check at x is equal to 0, what is the sign of f triple dash x? At f x is equal to 0, we get f triple dash x is equal to 60 into 0 square minus 120 into 0 plus 130. That is, what are we getting? We are getting this as 130. Okay, uh, plus 30, not 130. We are getting this as 30 only. Okay, now under this
Okay, sir.
circumstance, if we get the third derivative not equal to 0, remember this, we are not bothered about the sign, whatever we sign we get. If we get the third, if the second derivative is 0, and if the third derivative is not equal to 0, then we say that x is equal to 0 is a point of inflection. X is equal to 0, we say, is a point of inflection, also sometimes called as the stationary point. Now what is the point of inflection? It is also called as the stationary point. Now this
The
situation you will
stationary.
get in very few cases. Okay, very few cases you will get point of inflection. Most of the cases you will get second derivative either positive or negative. You will be able to determine the local maxima or minima. F triple dash x not equal to 0, you will get in very uh, very rare cases. Okay, we define the point of inflection at this. What do you mean by point of inflection?
Uh, yes.
A point at which f dash x is equal to 0, but there is no local maxima or minima. There is no local maxima or minima at that point. Understood? That is,
Yes, sir.
although have f dash x is equal to 0 at that point here, although we have f dash x is equal to 0, but still there is no maxima or minima at that point. That means x is equal to 0 is called a point of inflection, or sometimes called as a
Inflection.
stationary point also.
In
Okay, so that
stationary point.
this is what
Inflection.
point
Okay,
of
sir.
inflection means. First of all, you take in this problem fx is equal to x to the power of 1 by x. Okay, so how do you differentiate this function? Okay, let us say y is equal to it. Instead of taking fx, let us take y is equal to this. Okay, you can take fx also, no problem. Let y is equal to this. Therefore, how do you differentiate this function? You see that one function is raised to the power of another function. You take log on both sides. Log y is equal to 1 by x log x is equal to, I'm sorry, this is not 1 by x. You take, yes, it is equal to 1 by x log x. Yes. Okay. Now you differentiate both sides. You find dy dx. Differentiating both sides, with respect to x, we get 1 by y. Implicit functions, remember? Logarithmic differentiation and implicit functions is equal to 1
Yes,
by
sir.
x into ddx of log x. ddx of log x is 1 by x plus log x
Yes.
into ddx of 1 by x is what? Minus 1 by x square.
Minus
Okay.
1 by x square.
So what you are getting here is, now if you take the LCM, you are getting 1 minus log x by x square. Okay, that means what is dy dx? That means dy dx is equal to y into 1 minus log x by x square, which is equal to x to the power of 1 by x into 1 minus log x divided by x square. Okay, this is what we get. Therefore, for what is the condition for local maxima or minima? That dy dx is equal to 0. For local
0.
maxima or minima, dy dx is equal to 0. So what does dy dx is equal to 0 mean? It means x to the power of 1 by x into 1 minus log x by x square must be equal to 0. That means 1 minus log x must be equal to 0. Why? Because
Yes,
x
sir.
to the power of 1 by x cannot be equal to 0. That means you get log x is equal to 1. And log x is equal to 1 means x is equal to e, right? From the definition of log, this is natural log. Log x is equal to 1 means you have the base e here, right? So x is equal to e to the power of 1. It means x is equal to e. Now at x is equal to e, we are going to check the second derivative. Okay. So we're going to differentiate again. Okay. So how are we going to differentiate once again? You will start with, it is better that we differentiate this. Okay. In order to find dy dx. So we have, it is better always to start here, the differentiation. Okay. At this stage. Because if you start the differentiation at this stage, here, you will have to deal with, you'll have to use the u by v rule. So we'll escape that u by v rule. Okay. So what we do is we have 1 by y dy dx is equal to 1 minus log x by x square. Okay. That means what do we get here? You differentiate again both sides. You remember successive differentiation?
Yes, sir.
Differentiating both sides with respect to x. We get, what do we get here? You use u into v rule, 1 by y ddx of dy dx plus dy dx into the ddx of 1 by y, right? Which is equal to,
Yes, sir.
now you can use a u by v rule here. Okay. If you use your u by v
0.
rule here, what will it? Okay. So if you use your u by v rule here, then what are you going to get? V ddx of u minus u ddx of v
V.
divided by v square, right? So what are you getting here?
Yes, sir.
You are getting 1 by y d2y dx2 minus ddx of 1 by y is what? Minus 1 by y square into dy dx, right? And 1 dy
Yes, sir.
dx was already there. Okay. And if you differentiate this, what are you going to get? You're going to get, I'm not doing the actual differentiation. Okay, you'll get -2 plus -3 plus 2 log x divided by x cube. This is what you're going to get. Okay, so what are you getting here? 1 by y d2y dx2 minus 1 by y square dy dx square is equal to -3 plus twice log x divided by x cube. Okay, so now
Okay, sir.
that means, now see here, we need to check the sign of d2y dx2, right? At x is equal to e, right?
Yes,
Now
sir.
at x is equal to e, what is the value of y? At x is equal to e, what is the value of y? Y is equal to x to the power of
Uh,
1 by x means
X.
e to the power of 1 by e, right? This is the value of y, right?
Yes, sir.
So therefore, if you put it here in this
Yes, sir.
expression, because you simply need to find out the value of, check the sign of d2y dx2, right? If at x is equal to e, y is equal to this, and what is the value of dy dx at x is equal to e? Dy dx is 0, right? Because only on
Yes, sir.
equating dy dx is equal to 0 here, we got x is equal to e, right? So therefore,
Yes,
at
sir.
x is equal to e, the value of y is this, and the value of dy dx is this. Put these in this. Therefore, what is the value of y we are getting? 1 by e to the power of 1 by e. Okay, d2y dx2. Okay, minus, now dy dx, this part will become 0 because dy dx is 0. 0 is equal to -3 plus twice log e. What is the value of log e? Log e is 1, right?
Sir, log E. Yes, sir.
So what are we going to get here? We are going to get d2y dx2 is equal to e to the power of 1 by e into -3 plus log e is 1 divided by e cube, right? So what is the sign of this? Can you tell
Yes,
me
sir.
what is the sign of this? This is positive. This is positive. Only this is
Yes, sir.
negative. That means the sign of this is less than 0. Therefore, at
Yes,
x
sir.
is equal to e, there is a point of local. Which one? There is a point of local what?
Maxima. Minima.
Maxima. Because second derivative is negative. You need to find out the maximum value here, right?
Yes,
And
sir.
what is the sign of the derivative here? Negative. Negative.
Negative.
Second derivative is negative. Then we are talking about local maxima.
Yes, sir.
So therefore, is the point of local maxima. And what is the maximum value? You put it in the function. Maximum value is equal to y in the function. You put this value. What is the function given here? What is the function given? This one, x to the power of 1 by
Yes,
x.
sir.
You put x is equal to
Wait.
e here. So you get e to the power of 1 by. Understood? Now that is how you calculate
Yes, sir.
this. Okay. Now, uh,
Yes, sir.
cost per article is given to be, this is your number 6 here. The cost per article is given to be 3x square. C is equal to 5 plus 48 by x plus 3x square, where x is the number of articles manufactured per hour, where x is the number of articles manufactured per hour. Okay, you need to
Okay,
find
sir.
the minimum value of C. Okay, So this is where, and C is what? C is given to be the cost per article. Cost per article. Okay. So you need to find out the minimum value of C. So first of all, what we are going to do is we are going to differentiate this dCdx.
Okay.
Okay. dCdx will be what? 0 plus 48 into minus 1 by x square plus 6x, right? So this will be
Yes, sir.
6x minus 48 by x square. This is what you are getting a value of dc dx. Now for local maxima or minima, what is the condition? What is the condition?
So,
That is the first derivative is 0, right?
follow. Yes, sir.
So dc dx is equal to 0. So if you put dc dx is equal to 0, what are you getting? 6x minus 48 by x square is equal to 0. That
So,
means 6x is equal to 48 by x
yes.
square. That means 6x cube is equal to 48. That means x cube is equal to 48 by 6. That means we're getting 8. If x cube is
Yes.
equal to 8, then what is the value of x? It is cube root of 8, which is 2,
Yes, sir.
right? So we're getting only 1 point, x is equal to 2. Therefore, at x is equal to 2, we need to check the second derivative, right? So what you do is you differentiate again. Okay,
Yes.
you differentiate again. If you differentiate again, you get d2c dx2. You now start differentiating this function. You get what? 6 minus 48. And what is the derivative of minus 1 by x square? In fact, 1 by x square, it is minus 2 by x cube. So you're getting what?
Yes.
6 minus 6 plus, in fact, 76 by x cube, right?
Yes, sir.
So now what do you need to check? You need to check the sign of d2c dx2 at x is equal to 2. At x is equal to 2, d2c dx2 is what? 6 plus 76 by 2 cube, which is what is the sign? Positive always, right? So
Yes.
therefore, x is equal to 2 is the point of what? Local
Minima.
minima. Okay. So when
Yes.
when x is equal to 2, we get the minimum value. So therefore, what should be the minimum cost? Put x is equal to 2 here in the function given.
Yes, sir.
Therefore, minimum cost per article. This is the cost per article, right? Yes. Minimum cost
Yes, sir.
per article is equal to minimum cost per article is what is the function given here? 5 plus 48 by x plus 3x square. Okay, so this is the minimum cost. So you cancel this, you get 5 plus 24 plus 3 into 4 is 12. So this is 29 plus 12, which is 41. So minimum cost per article is 41 rupees.
Yes, sir.
Understood? So this is as simple as that. Let us do the next one. Find the turning points, turning values. Last one from this exercise. Whatever sum that I have done with you, these are sufficient. Okay. Now you can solve all the exercise problems, even applied problems you can solve. If you understand whatever examples I have given you, those examples are more than sufficient. Number 10. The question is find the turning values of the function. Let us assume let fx is equal to minus x cube plus 12x square minus 5. Distinguishing whether the local whether the point are maximum, minimum, or inflectional. Okay, so you will get certain points here. After you equate second derivative, first derivative equal to 0, then you check whether the point are local whether the points are points of local maxima or minima, or whether they are point of inflection. So first differentiate this. F dash x is equal to, you get what, minus 3x square plus 24x. Okay, therefore for
Okay,
local
sir.
maxima or minima, f dash x must be equal to 0. That means minus 3x square plus 24x is equal to 0. Now you take 3x minus 3x common, you get what, x minus 8. That means what are the points that you are getting? X is equal to 0 or x is equal to 8, right? Now we are going to check for the second derivative. What is f double dash x here? F double dash x is minus 6x plus 24, which is minus 6 into x minus 4, right? At x is equal to, first point, at x
Yes,
is
sir.
equal to 0. What is the sign of f double dash x? Minus 6 into 0 minus 4. So you get what? 24, which is greater than 0. Therefore, what is x is equal to 0? X is equal to 0 is a point of local
Well, minima.
minimum. Okay. And what is the minimum value? Minimum value, put it in the function. Minimum value is equal to f0 minus 0 cube plus 12 into 0 square minus 5, which is minus 5. This is the minimum value. Now we check for the second point. What is the second point? X is equal to 8. At x is equal to 8, f double dash x, put the value here, minus 6 times 8 minus 4. So what are you getting? Minus 6 times minus, this is less than 0, right? So therefore x is equal to 8 is the point of
Local minima.
local minima, maxima. Second
Yes,
derivative is negative.
yes, yes, sorry.
Therefore, what is the maximum value? Maximum value is, what is the maximum value? Put it in the function. Minus
Yes, sir. Minus
8 cube
8
plus
cube
12 into 8
plus
square
7x.
minus 5. Okay. So calculate it whatever it comes to. I think it will come to 251. Come to 251. Okay. That is what. And what are the points?
Yes, sir.
What are the turning values here? Turning values? Turning points, in fact. What are the turning points? See, at x is equal to 0, what is the value of, what is the minimum value? 0, 5. So turning points are 0, minus 5, and at x is equal to 8, what is the value here? 251. 8 comma 251. These are the turning
251.
points. These are the turning points. Okay. So that finishes this exercise.
Okay, sir.
Okay, so let us see what is the next exercise that we have. Then I think a plus b plus c, f dash x, you have got 2x plus b, and x is equal to minus b by a. So f double dash x is 2a. And the maximum value is 20. Maximum value is 20. Number, 11. 2 is 20. Hmm. I think this is okay. Fine. Let us move on to the next one. Find the maximum profit that a company can make. Okay. I want to finish this exercise today so that I can move on to the applied problems next in the next session. So the question here is not maximum profit. We are not supposed to do this. We are supposed to do find the point on the curve. The given curve is this is number 16C. The given curve is x square equal to 8y, which is nearest to the point. Find the point on the curve which is nearest to the point. Okay. This is 16. Hmm. The given curve is this. So for nearest point, what do we do? For nearest point means what? Nearest point means that distance has to be minimum, right?
Yes, sir.
Nearest point means distance has to be minimum. So if I get dy dx here, that means second derivative distance between that point and the what is the distance between 2 points? Um, hmm. Distance between 2 points. And I'll finish this next in the next class again.